Hey, it's Bill Tromley from Tromley Tool in East Troy, Wisconsin. Today's video is going to be kind of introductory to welding for metal shapers. I'm not going to show a lot of the actual welding process for two reasons. One, I don't have any welding lens to put over the camera, and I just don't really want to take the time to figure that out. And secondarily, there's a lot of videos on how to weld on YouTube and social media. So this is going to be some just basic setup stuff and things to think about. I'm going to compare TIG welding and gas welding. And we're going to do steel today, and then I think in the future we'll do a video on aluminum if people are interested. Why only TIG welding and steel? Those are the two most common. I mean, nowadays I think TIG welding is the most common for metal shapers. There's still gas welding that's being done. There's nothing wrong with that. I'm not going to cover MIG welding. If there's a lot of interest in that, I could do it. But to be honest with you, MIG welding is great for building trailers or frame rails, and not necessarily all that great for doing metal shaping. I know a lot of people do it, but I think you'd get a better quality product much quicker and easier the sooner that you could transition out of MIG welding and go this route. For me, I would rather gas weld a metal panel together than MIG weld metal panel together. Why? MIG is easy, right? It's the easiest of all welding processes. You know, it's like using a squirt gun in essence. Pull the trigger and you go. The welds are very hard. You'll know it when you got to grind it or plenish it. It is so hard it can wreck body hammer faces or plenishing hammer dies. And grinding and dealing with that, you know, it's just a lot of work versus using one of these other two avenues. What is the benefit of oxyacetylene? Almost everybody has it, right? If you don't have a set that you purchased, it might have been a hand-me-down from your father or grandfather. It's inexpensive to get into it. You know, our local Tractor Supply, I just saw I had one on the shelf. Came with the two regulators and the torch with tip sets and everything for, I don't even know if it was $100, maybe. You know, inexpensive route to get you into welding. And you can produce high quality welds as far as a metal shaper. What's the downside of it? Oh, and the benefit then is you could use like a rosebud for a heating tip. You know, for heating up something big. Also with a cutting torch on it, right? You know, pretty versatile tool for what it is. What's the downside of oxyacetylene? You get a pretty big heat effect zone. You know, I'll weld today and you'll see it'll appear to be much wider than TIG weld. You know, TIG weld is very precise versus oxyacetylene. And I can use a very small tip, and we will. You know, and then it's dirty, meaning that when it's done, there's a lot of scale on the surface. And that all comes right off, right? You could sand it off or wire brush a lot of it off, and it does just fine. You know, a lot of stuff was done that way. For guys that are doing body lead, oxyacetylene torch is hard to beat for body lead. You can't body lead with a TIG torch. At least I've not tried it. I don't know why you would, but so there is benefit to it. The system that I have here is a Miko torch. For guys that knew Kent White, that's what he used. It's a small, compact, lightweight. Get tips for it and everything else. They have different length arms. And I have two of these setups. One is oxygen oxyacetylene welding. And then I also have the same thing for oxygen hydrogen welding for welding aluminum. With this, I can weld aluminum with oxyacetylene. You just have to use a flux. And then there's oxygen hydrogen. And the oxyhydrogen stuff we'll show if we do aluminum video. Lightweight hoses, works well. This stand here, I made this stand. This is a gas saver on top, up here. Let's see, yeah, right there. You can see it has a lit flame on it, and it's a control valve. And the torch hangs off this arm. Set this camera down. See, like that. So when the lever goes up, gas is flowing through the torch, and I can easily set this. Beautiful thing with this is, I put this on there, auto shuts off. You know, I don't have an open flame across my workbench. It's a safety thing. It saves on gas. Another beautiful thing. But what the pilot lamp does is I can have my headgear on and try and attack stuff, and you're in the moment and you're thinking about this plus 10 other things, and you don't have to be worrying about this. Is that I can easily go like this and it's reset. My torch settings are the same. I'm not changing anything. Where I set it is where it's at right now again. So it makes it easy to just go back and forth. Pretty slick deal. I highly encourage you, if you're going to go gas welding, get a gas saver. On mine, I made my end different. Normally these gas savers come with a hook. Let me see here if I can change that. Yeah. What this is a piece of material. I put a keyhole in it, like that. And the benefit is this is contained, right? I can carry this thing up, I can move it around. The torch isn't falling off. With the hook deal, you kind of had to drape it over the top of the hook, which I didn't like. I didn't want the hoses going across. You take any rubber hose long enough and you do that, it kind of takes a set and damages the hose over time, which I didn't like. The air compressor just kicked in. Let me pause this. Okay, we're back. So with the lightweight hoses, that allows you to move real easy. The gas saver allows you to be able to go back and forth to using the torch, really simple. What I have it on is it's mounted on a stand. This stand here, if you can see down here on the base, whoops, yeah, the base there. What the base is cast iron gumball machine bases. Find them on eBay, pretty cheap. What's nice is the thread that's in the base is standard water pipe, NPT thread. I think it's 1/2 inch NPT, I'd have to look it up. So you can get a piece of pipe then from the local home improvement store. And I got this one, it's, I don't know, 3.5, 4 feet, something like that. It seemed like a good height, right? Something that I could be at the welding bench and I could just grab it and go. And then what I did is I welded on this hook here. Beneficial to hold the striker on it, stuff like that. And then what this is in here is brush, wire brush. Now let me see if I can push this out. What this is a simple wire brush you use on the end of a drill. A 1/4 inch shank. And I found a piece of chromoly tubing. We have airplane tubing here in the shop that fit this really well, and this pushes in there. Well, I'll have to deal with it. Let me see. Well, anyways, what I had was the bristles were right at the end of the piece of tubing, so they're all standing up like this. And it makes it great for cleaning off the end of the tip. I can just go like this. And now when you look at the end of the tip, it's all nice, clean, and shiny again. The tips get contaminated over time. It's in the flame. When you're using flux for aluminum welding, that flux kind of builds up on the tip. So it's a simple tip cleaner. The cast iron base is heavy enough that this thing is safe, right? It's not tipping over in the shop, that kind of stuff. I like it like that. One important thing is check your pipe and hose connections. I was welding yesterday with this, and all of a sudden had a flame come out at the handle of the torch, right here at this joint, acetylene. And all of a sudden, poof, and I had a little bit of a flame. I just put it out with my fingers, and it's from this not being tight enough. And that was failure on my part from not checking my connections from time to time. We do change this torch head over to a much bigger torch with a rosebud on it. So when I converted it or switched it back to this torch, I didn't have the fitting as tight, and I should have checked it. It's very important to do. Not only are you losing gas, which is expensive, you could also be drawing in atmosphere, which is screwing with your mixture and causing flame issues. And also it's just damn dangerous, right? To have a leaky joint which could catch fire. So that's important. This is a leak detector. You don't need that. You could use, oftentimes we use Dawn dish soap and a little brush, put a splash of it in there, water, acid brush, and go over the connections. We do that on all of our bottles. Argon, acetylene, hydrogen, everything. One thing to be careful with is oxygen. You want to keep your oxygen connections extremely clean. If you have oil on your hands, don't be playing with the oxygen connections. Because any kind of dirt or contaminant, even on the flare fitting or something like that, when the oxygen is turned on, can become explosive and you can blow it up. It is a real thing. A lot of weld shops or welding stores will have photographs on the wall of torches that have blown up, and usually in the guy's hand, because of foreign contaminants when dealing with oxygen. So be very careful with that. Always take your bottles, and I don't care what it is. If it's a pressurized bottle, chain them or strap them to the wall, a machine, something. Don't leave them freestanding. If they are, always have the big cap on the top. Guy I work for, Gil Zeitz, I've talked about him maybe a little bit in the past. Excellent machinist. He was in the Korean War, ran a mobile machine shop, and he said they had a bottle tip over and it broke off the valve on the top of the bottle, and he said it went across the shop and out through the shop wall. So it's no fooling. You gotta remember it's a couple thousand PSI in there, a lot of pressure. So be careful with this stuff. Chain up your bottles. I go in some shops and you see them just freestanding, and that just bugs the heck out of me. That's a bad idea. So, kind of basic entry-level stuff to think about. Do you need a gas saver? No. You could use a striker. Yes, it works. Many different things. Do you have to have a gas saver on the stand? No. There are electronic spark boxes is the way I would describe it. I know Kent White had one. He didn't like the idea, from what I remember, of the open flame on the pilot lamp. So he would have his pilot lamp closed, and he had another spark box on top of it. I think it took a AA battery or 9-volt battery, and you'd push it and it would shoot an arc across like a spark plug. That stuff's out there. Whatever works for you, right? With your budget in mind, so to speak. So all good stuff. What about TIG welding? TIG welding came out during World War II. It was developed by Northrop Aircraft. There's some stories in regards to that. Some believe it was to help settle the issues they were having with welding magnesium. Possible, but came out during the war nonetheless. The initial gas they were using was the helium. That's where you hear the term heliarc. You know, a guy's an old guy when he goes, yeah, you know, I'd use a heliarc on that. It's like, okay, they haven't done heliarc in a long time. We use acetylene gas, and you know, I could be wrong in that, but it just tends to be funny, I guess. Benefits of TIG welding. Very versatile. Well, and we could talk about that too. How versatile is oxyacetylene? Versatile to a point, right? It's good in steel. But if you're going to weld aluminum or stainless steel, you got to use a flux. You can use oxyacetylene, oxyhydrogen, and magnesium, as long as you have a flux. With TIG welding, you don't. We never use a flux. We're using an argon shielding gas. And beneficial? Sure. Versatile? Yes. You know, in-house, I TIG weld steel, stainless steel, Inconel, titanium, magnesium, aluminum, all with one machine, all with one gas, and basically all with one grade of tungsten. Versatile? Yes. Are the machines expensive? Not like they used to be. Prices now are coming down pretty good on that stuff. And they will last a long time. I mean, our TIG welder here, we bought that in 2001, and it was a used unit then, still going strong. It's a machine called, manufacturer called Thermal Arc, 200 amp TIG welder. People call and they'll ask me, they go, you know, I'm thinking about getting a TIG welder, you know, which model should I get? You know, like how much current? And it's like, buy a unit that puts out as much current as your budget can allow. What do I mean by that? You see some TIG welders and they're 120 amp TIG welder. Well, that's not a lot. This machine, it goes up to 300 amps, maybe 200 amps. We don't run out of current that way, right? We have enough heat to be able to put into the part. So buy a machine that puts out a higher output. If you're only ever doing sheet metal, 100 amps is fine. People go, I'm only ever doing sheet metal, and then 3 months later they're going, you know, I can't get it hot enough to do this frame rail. It's like, well, you bought a small machine, you can only do thin stuff. So higher current capacity is good. Another thing that's important is an AC and DC machine. We weld steel and stainless steel and materials like that in DC, direct current. For aluminum, we're using AC and alternating current. So you want an AC-DC machine. Pretty important thing. When it comes to controls, for me, I use a foot pedal. This is our foot pedal here, old foot pedal. Still works great. Why? Well, basically, it's what we grew up on. In my shop, 98% of our work is bench work. I'm working at a welding table. We make a lot of smaller stuff. I'm not going to the project, right? I'm not welding in a car body. I'm not welding a roll cage in a car. So a foot pedal works great for that. It's what I grew up on. Do I have a hand-controlled torch? I do, for that 1% time or 2% time that I need it. And what that means is for TIG welding, this is still called a torch. Just like the TIG, oxyacetylene torch. This is a TIG torch. No hand control, but they'll have ones where it's a push button or a thumb roller on it. A friend of mine, Mike out in Philadelphia, he has one that I think has a slide on the side that he said he liked. Mine is push button. It's okay. With the push button, you got to preset a lot more of the settings so that when you click it on, the machine is at the values you want. So you don't have as much variance or variation on current, and that becomes important. practice with it. Ask your friends, what do they like? You know, that's important too. And see. One thing is my torches are water cooled, which means I have a unit, it's called a chiller. It's mounted underneath the TIG welder, and it's putting a glycol solution through the torch, and that's cooling the head. Why is that beneficial? If you look at air-cooled torches, the torch head is a lot bigger in size. And it takes longer for everything to cool down. The cups are generally glowing red hot by the time you're done, everything like that. With a cooled torch, these run cooler. Makes it easier that when you dip the tungsten, I can change it out quicker. With all of these, you can get these caps at different lengths. This is a full-length cap, this black piece, because we use full-length tungstens. Yeah, like that. You know, and that tungsten's about 8 inches long. That's kind of the standard. They do have shorter cups, these pieces here at the back, these caps. But then you got to have cut tungsten. For me, because we're doing bench work and whatever, this is fine. Do I run shorter ones? I do in tight spots. You know, I have ones that they go progressively shorter, probably in 2-inch increments or 1.5-inch increments, all the way down to one that's just a short cap here at the end. Pretty simple. These ceramic cups are removable and interchangeable. You can get them in different sizes. For me, this is a number 5 cup, I believe. Probably the most common that I use. You see nowadays, they're called gas lenses, where they're much bigger, you know, about like that. Some of them are clear, they're Pyrex, you know, and people go, well, you need those. That way you can see through the cup to be able to weld it. It's like, I haven't seen one guy yet that proved me that he could see through the cup while he was trying to weld. Most of them are ceramic. I have them. One thing is, though, is they don't seem to be very resistant to being hit. You know, this thing will drop and hit the floor, you know, somewhat often, or hit the tabletop or something like that. The bigger cups tend to shatter and bust. You know, this one's hit the floor. I think the last time we changed out this cup, we're probably coming up on a year of TIG welding, and we're welding in our shop daily. You know, we're not welding all day. Some days we are. But I mean, virtually almost every single day the TIG welder is on and running for something. And so we're getting a lot of mileage out of this, which is a good thing. Right? Because consumables are expensive. In here is a collet and a little tip piece and all that stuff. When it comes to tungsten size, I think this is 3/32 tungsten. You can get them down into smaller sizes, 1/16, 40 thousandths. You also get them bigger up in 1/8 inch. How do you know what size tungsten to use? It's based off of how much current you're putting into the part. So I have that written down. So 40 thousandths tungsten is recommended from 15 to 75 amps. 1/16 tungsten is 75 amps to 150 amps. 93 thousandths tungsten is 150 amps to 250 amps, approximately. Could you use a bigger tungsten and weld at lower amperage? Yes. Does it matter? If I'm welding thin aluminum, it does. What it's happening is by having the smaller diameter tungsten, the tungsten is properly being heated to the right temperature to work properly, in my opinion. Remember, these ideas are my opinions. If you go on weld.com and whatever, you know, some of their information will vary, and it's good to get all of this stuff from different welders. So, but that's good basic kind of stuff to consider. Question, how far do you hang out the tungsten past the end of the cup? It's a common question that I get asked with new welder guys. You know, can I hang this tungsten out that far? No. Why? Well, there's a gas that is coming out around the tungsten that is coming out through this cup. That's why the end of the cup is open. How far do you hang out the tungsten? Diameter of the cup. That's why one of the benefits of a big gas lens is you'll see them, they can hang out the tungsten much further because they have all that gas coverage coming across the top of the tungsten. Can I hang this out potentially a little bit further in certain applications? Yes. Where? In a tight corner joint. What's happening? Argon is flowing into the corner, and the corner is containing the argon. And the argon is a shielding gas that is keeping the atmosphere away from the weld. So because of that, I can get away with hanging that out. If you reach your limit, what you can do is they sell ceramic tips. They're very small diameter and long length. They're designed to get in those corner joints. How often do we use those? Very rarely. Why? Well, they're easy to break, right? And if I don't need it every day, I only use them for that special application, then that's what I use them for. How often? Once every 2 years. Is it good to have them? You know, a couple. But probably you and 3 of your buddies could buy a box of 5 of them, split up the box, and everybody would be fine for a long time. Do you need gas lenses? Big gas lenses. They look cool. And a lot of new guys have them. And I had a guy once tell me, he goes, man, you're not welding with a gas lens anymore. Oh my God, how can you do that? You know, you're doing aircraft welding. It's like, you know, millions of miles of aircraft welds were made on that cup just fine before gas lenses even came out. The gas lens stuff is probably within the last 5 years, maybe 10. I don't know. Something to think about. So let's see here. How much gas flow do we need as far as argon? It's an important thing to think about. A friend of mine here on the field restoration shop, they have a TIG welder. They never use it. I was over there in their shop and I had to weld a little bracket piece. So I fired up their welder because I didn't want to move mine over there. And this thing welded like a plasma cutter. I had never seen something like it. You initiate the arc and the arc is just buzzing all over the place. And I look and they got the bottle cranked up. So I'm taking it and turning it down, turning it down, turning it down, turning it down, and all of a sudden now the TIG welder works just beautifully. And they look at me like, wow, we thought the welder was broke. Yeah, well, how does a plasma cutter work? Shoot an arc through past compressed gas. It's kind of what they're doing. So how do you know how much to set your regulator at on your TIG torch? 2 times your cup size is the best number. Number 5 cup, set your gas flow at 10 cubic feet per hour. Super simple. What happens if the gas flow is too low? Well, atmosphere can come in and contaminate the weld pool. What happens if the gas flow is too high? Well, turbulent air happens and it's doing this because you got so much airflow and it draws in atmosphere with it. What about with a gas lens? Does that principle apply? Not necessarily. So gas lens manufacturers have their recommendation as far as how many cubic feet per hour to run with that particular size gas lens. So go to that manufacturers for those specifications. But if you're running a ceramic cup like this, 2 times cup size, more than good enough. What about current settings in a TIG welder? This is something that gets discussed somewhat, and we all have kind of our different ways of going about it. For me, and I'll grab my pedal again. For me, where do I set how much current I can weld with on my machine? I set it at 1 amp per 1/1000th of inch of thickness of material. If it's aluminum, I add 10%. What does that mean? 19 gauge steel, AK steel, or 19 gauge car body steel, 40/1000ths of an inch thick. I preset my TIG welder to 40 amps. If I was welding aluminum that was 40/1000ths thick, I set my TIG welder to 45 amps. Couldn't you go more? Yeah, you know, within reason. Right? And that's how I do it. A friend of mine, Mike out in Philadelphia, great guy. And I really like Mike, and we get along quite well, I think. He has his machine at 200. And he works that way, and it works for him, and he does great stuff. So why the difference? Well, this is the way to think of it. This foot pedal is regulating the output of where I set my knob. So if my knob is set at 50 amps, the foot pedal is regulating from where the arc initiates to wherever the setting would be in your TIG welder, all the way down is 50 amps. If it's set at 200 amps, this is now regulating from 0 to 200. So the fidelity becomes less, in my opinion. And that's why I use that as a baseline setting. In other videos in the past, I say, settings, I don't discuss it or whatever, because you should go to what your manual states. And that is true when it comes to if you're going to be adjusting balance or frequency or things like that. When it comes to these baseline settings, or the things I'm discussing today, is basically good settings for any TIG welder that is out there, to a point. One of the questions that pops up, and it generally pops up with new welders, and what it is welders have trouble, so they go, it must be equipment instead of lack of practice. So one of the questions that pops up is, what grade tungsten should I use? On this chart here, this is a chart that I got through Ron Covell, excellent guy. And it says tungsten selection chart. Excuse me. Super simple, and it really kind of cuts through all of the technical aspects of tungsten. And because they do certain things for certain applications. When people ask me, what tungsten should I use? Go to what your welder recommends. Is the best place to start. Certain tungstens work better in certain pieces of equipment than others. In the exact sciences to it, why, I don't know. The tungsten we use is a gray band tungsten. And I'd have to look that up. Let's see here. Gray is 2% serrated. And guys go, are you running 2% serrated or 2% thurated? I don't know. I look it up. That's why I got a chart, right? I write things down so I don't have to remember. So, hope that all kind of makes sense. Let's see here. I think we covered everything. So we're going to go ahead and we'll do a gas weld first, and then I'll reset up and we'll do a TIG weld, and then we'll kind of get finished up. So let me just get set up. Gas welding headgear. I know there's that individual that's going to ask this. What lenses do you run? I run Burt Welds aluminum lenses. It's a number 5 shade. When it comes for aluminum welding, there's a more important aspect to that, and it's regards to the flux. We'll discuss that in aluminum welding. Can you use a TIG welding helmet for gas? I think if you could get the shade down far enough, you could. So we're going to go ahead and initiate and start a gas weld here. Let's see how well this works. Yeah, that's what's nice. Look at that. Torch is already preset, ready to go. When it comes to cone length, you want to make the cone length about 3 times your material thickness if possible. Neutral flame. Now it's taking a while for this to heat up because I have the torch, my vice grip right next to it. So the vice grip is acting as a heat sink. I'm going to go ahead and I'm just fuse welding this joint. People might hear the whistle noise and go, well, you're oxidizing. No, the whistle noise is coming out of from the gas flow through this dirty tip. If it was oxidizing, it would have a hiss to it. If you guys want to see how do you set up a torch, you know, like should it be carburizing flame, neutral flame, or oxidizing flame? There's a lot of videos out there on that. If you guys want me to do it, I can do it. But this video is more about to show you the difference between gas and TIG versus a lot of in-depth stuff in regards to one particular process. If you guys want that, let me know exactly what you want. Instead of just saying, well, a video on welding, yeah, be specific. Put that in the comments and then we'll do it. So now I will set up and I'll TIG weld. Okay. So when it comes to TIG welding, I always weld with TIG welding gloves. Why? You have a lot of current potential in this TIG welder. And I've had this conversation with other welders, like, really? I never thought of it that way. Well, think of it this way. If I'm welding with no gloves, steel filler rod, tungsten, shooting an arc out of here through the material. If this touches the tungsten, what happened? I completed the path through me in the process. And I don't like that. So, like in my shop, I won't allow our guys to weld without gloves. If you don't have leathers on and all that stuff, that's your choice, right? When it comes to safety gear, I always criticize this in the past. I say, you do you, right? That's what's important. Is it important to wear leather shop coats and all that stuff? If you're welding all the time, yes. What I found the most amazing was the big critics of the guys that were criticizing me for the work of not having all of the leather gear on openly admitted that they don't wear it themselves. So what are we talking about as far as leather? Shop coat like this, leather apron or leather arms on it, flame resistant coat. We have this for when we MIG weld. When we're doing heavy structural stuff, absolutely. Using my heat treat oven, absolutely. This, no. So, be safe. How do you know where to set your helmet? Auto darkening helmet, excellent. You know, I used flip helmets for years. When I went auto darkening, we still have the flip helmet, it's in the drawer. I like the Lincoln electric ones. My Miller helmet, I don't care for it. Big field of view, auto darkening, easy to see through, great helmet. Wide field of vision. Where do you set your settings on it on the inside? My shade is set at, let's see here, 10. 10 shade. The rule that I learned is go down in shade until you start where it's starting to imprint on your eye, go up a shade. Is there a more scientific way of doing that? Probably. Look it up, research it. Be safe. You know, you're playing with a lot of heat here. Stuff gets hot. You know, use your head on this stuff. Be smart about it. That's all I can tell you. Be careful where you throw sparks. You don't want sparks in your shop to catch other stuff on fire. Have a fire extinguisher around, fire blankets, and all that stuff. No fooling. You got a lot of heat here. You have a lot of energy potential here in the welder. Filler rod diameter. I generally go whatever the thickness of the material is approximately. You know, what happens if the wire is too thin? Feeding like crazy. What happens if the wire is too thick? It's a heat sink. You'll see it every time you dip, all of a sudden the whole welding process will slow down. And that's because the heat's being absorbed into the filler rod. So, something to think about. So I'm going to make a TIG weld pass on this, and then we'll show it and be done. I know it's a long video, And some people don't like that, other people do. So I guess if it's too long, go to the 20 market, take a break, and watch the last 20 minutes. So let's hear. Let's see. This first pass, not first pass, my first 1.5 inch was purely a fusion weld, or what we would call a autogenous weld. It'll be written down, it'll look like autogenous, as you see guys go, I autogenous welded. It's like, no, you autogenous. That's the proper pronunciation for that. That's a fuse weld. Beneficial, yeah, you don't have less to grind down or hammer in. But then the rest of this bead I'll use filler rod. So we'll try that. So you can just see the difference. And turn off the TIG weld. Okay. Great story. Some of you guys know in my videos in the past, I talked about Pat Brubaker out of Imperial Welding Machine Company in Hastings, Nebraska. The first day I met Pat was at a metal meet that was up in Minneapolis. I didn't know him. And there was a pickup truck cab, and they had cut the roof off the cab, and we were going to weld the roof back on. And someone had told him that, well, you know, Trombley does a little bit of welding. So he goes, I hear you know how to weld. And I said, yeah. And Pat said, well, we got to weld this roof on. Guys are convinced that it won't work, that we're going to cause so much distortion, it'll be uncontrollable, and we're going to have all these problems. And he said, are you interested? I said, sure. So I started on the passenger side, Pat was on the driver's side, and I went aft along the passenger side and along the back of the roof. Pat went forward along the driver's side and along the front of the truck roof. And him and I welded the roof on in 12 minutes. One pass, one bead, continuous. We already had the roof tacked in place and plenished, so everything lined up. And off we went. And a lot of people didn't think it would work, and it worked beautifully. One thing that Pat talks about is he said, you know, and he's right, when we looked at it his heat effect zone was narrower than mine, and he moves at a faster speed than I do. And where mine was slightly wider. But it was both of them, the heat effect zone was consistent, and that's what's important. Pat said that my beads look better, and I disagree. I think our beads look the same. It was just a matter of our feed rate going around. What are we talking about? Let's see here. Yeah, it's cooled off now. Heat effect zone. That is the bluing area right here. So you can see where it's narrow from there to there is where I fuse welded it, no filler rod. Now you can see where I added the filler from here to there. Because I'm adding in the filler, I tend to slow down a little bit. So what happens? The heat effect zone gets a little bit wider. Now you look at the gas weld here. Look at the width of the difference. Why? Well, I'm not a gas welder where I'm welding all the time. So maybe I could have improved on it slightly. But also I'm using a flame. It's a wider flame. It takes a little bit longer to get the heat into it, to get everything molten. So because of that, it tends to heat up a little bit more. What's the thing that you notice though is it's a consistent width from here to there. That's consistent all the way across. Same thing with here. It's a consistent width from there to there, and then from there to there. Consistency is what you want. What about penetration? If you look at the TIG weld there, perfect penetration. Yeah, especially where I added the filler rod. Less penetration right there where I fuse welded. I would say the penetration is at 100% at spots and probably 95% in other spots. It's almost perfect. On my gas weld penetration, I have full penetration for almost all of it. Why is penetration important? It's what gives you the strength. It's hugely important. People ask me, they go, where do I set my settings? If it's any kind of material and it's important, your patch panel on your car is important, right? You can't have this thing break out. Make sure that I can give you all the settings and all the science and all that stuff, but you need to weld it and then flip it over and say, do you have penetration? If you don't, either slow down your travel speed or increase your current. Also, it could be the distance of how far you hold the tungsten above the surface. But verify it. Don't weld the whole roof on a pickup truck like what Pat and I did and then realize, well, I don't have any penetration. Imagine the mess that would have created, going back now and trying to do that all over again. On that roof as an example, both Pat and I had perfect penetration. Like it was like clean textbook all the way around. Why is heat effect zone important? Where you want it to be this consistent band. Well, in this area is where the shrink occurs during welding. All welding causes a shrink. It has to. It does. You can't get around it. You'll see online, guys go on social media, you only weld an inch and then blow an air hose on it. Only weld a little bit and weld an air hose on it. Like, no, you look at their heat effect zone and it does this. What happens? The shrink rate where the weld occurred goes like this. Fixing that is hard. When the heat effect zone is consistent, that is telling you that the shrinkage is consistent. So what happens when it shrinks? This is the most important thing to think about in this regard. I learned this from Peter Tomasini, probably the first time I ever met him, never forgot about it, was if the panel was good before you welded it, the only issue with the distortion is in the weld, which means the only place you fix is the weld. So if this is a consistent shrink, it means it's a consistent stretch for me to fix it. And it becomes easy. Stitch welding all over the place and all that stuff. Then you look at the panel and it's all contoured and cratered and everything else. That's a problem. And people look at it and go, well, all that distortion. Look at this distortion in here. A little bit more distortion in the gas weld side than the steel side. Yeah, light planishing hammer, and this would be straight. It gives you a consistent result. It's easy to fix, right? And always remember that. If the panel was right before you welded it, the only issue lies where you welded it, which means if the shrink is here and I got to stretch it, only stretch here. You'll see guys, especially in the beginning, you tell them only stretch the weld, and before you know it, they're over here stretching. It's like if this was good before you welded it, then it's fine now. So only stay in that area. And the panel will straighten right back out. If you don't believe me, try it my way and give it a shot. And then post your comments down below. So I know this is a long video, and let me know if you like it or if you think these should be short. I was told that one of the problems with Trombley's videos is he just talks too much. He just doesn't show stuff. It's like, well, here's my idea on that. Most videos are people showing stuff and not explaining it. The goal of this is to be the opposite, to be able to explain it, and then you guys go practice it and try it. let me know what you think. Like, subscribe, tell all your friends, and have a good day. If you're interested in aluminum welding, the same comparison between TIG and gas, we can do that too. So thanks, have a good day. Bye.